Area is a word you hear a lot in geometry, and it's a measure of how much space is inside a shape. For example, take a look at these two shapes. This one has a smaller area because there's not too much space inside it, while this one has a bigger area because there's much more space inside. Next, take a look at these four shapes. Which of them has the largest area? Which one has the most space inside? Exactly, this shape has the largest area. Now a more precise definition of area is that it's the number of unit squares that fit inside a shape. What's a unit square? Well, it's a square whose sides all have a length of 1. So for example, let's say we want to find the area of this shape here. Let's draw in a few light grid lines to help us out. This shape contains 6 of these unit squares, so it has an area of 6. So next, try finding the areas of these three shapes. Nicely done. So these shapes have areas of 5, 24, and 18. Now suppose we take a unit square and then cut it in half like this. What's the area of this smaller shape over here? Great! So this is an example of an area that is not a whole number. This shape has an area of a half, or 0.5. Next, let's return to our shape that had an area of 24, and let's cut it over here. And now let's move this part of it over to the other side. So it used to have an area of 24, but now that we've rearranged it, what's its area? Nicely done! When you cut up and rearrange a shape, you don't actually change its area, so it's still 24. Let's double check that by counting up all the squares. So we have 20 complete squares here, but then we have these parts of the square left over. If we rearrange them a little, then we have a few more squares, 21, 22, 23, 24. So yes, this area is 24. Suppose we cut this shape with area 24 into 2 equal halves. What's the area of this half down here? Nicely done. There are a few ways you could have solved this. One way is to take the area of the entire shape, 24, and divide it by 2, giving you 12. Another way is to count up the unit squares. We have 8 whole squares, and then the leftovers. Again, let's rearrange them, and now we have a few more squares, giving us a total of 12. Next, say you have two shapes with areas of 13 and 22. Now if we combine them, what's the total area of this entire green shape? Right, when you combine shapes, you can add their areas. So this new, larger shape has an area of 13 plus 22, or 35. Now take a look at this shape. Finding its area is pretty tricky because its edges are curved. But go ahead and try approximating the area of this shape. That was a pretty good estimate. If you count up the number of whole unit squares on the inside, there are 16 of them. So this shape has an area that's greater than 16. But it also has to be less than this area, which is 36. So it's somewhere between 16 and 36. The exact area of this shape turns out to be approximately 28.274. And in a later lesson, you'll come up with a way to find the exact area of shapes like this, which are called circles. Now one last thing. Let's talk about units for area. We said each side length here is 1, but is it 1 centimeter, 1 meter, 1 mile? Depending on the units you use, like meters or miles, you can have unit squares with very different areas. Let's say each of these sides is 1 centimeter. The area of this square is still 1, but we write it like this. You can read this aloud as 1 square centimeter. You can also write it like this, or even like this, where SQ is an abbreviation for square. 1 square centimeter is defined as the area of a square whose sides each have a length of 1 centimeter. So for your final challenge, say you're planting a small garden that has this shape, and the length of this side over here is 1 foot. Then what do you think is the correct area for this garden? Is it 4 square centimeters, or 4 square feet? Let's come up with a formula for finding the area of a rectangle. But first, let's make sure you remember what rectangles are.
Which of these quadrilaterals is a rectangle? Nicely done. This is a rectangle. Now, the area of a shape is a measure of how much space there is inside of it. Another way to think about area is the number of unit squares that fit inside the shape. And a unit square is a square whose sides have a length of 1. Now, this side of our rectangle has a length of 5. This side is 5 times longer than the side of a unit square. And this side of the rectangle has a length of 3. You'll often see various names for the sides of rectangles. Sometimes you'll see length and width, other times you'll see base and height. For now, let's stick with base and height. Let's just add a few more lines here to help you calculate the area of this rectangle. So, what's the area of a rectangle with a base of 5 and a height of 3? In other words, how many unit squares fit inside this rectangle? Right. The area of this rectangle is 15, because you can fit 15 unit squares inside. Another way to calculate the area of this rectangle is to multiply the length of the base and the length of the height. So that's 5 times 3, which gives you the same answer, 15. Now suppose you have another rectangle. Say its base is b units in length, and its height is h units in length. What's the area of this rectangle? Your answer should have both a b and an h in it. Well done! The area of this rectangle is b times h. By the way, there are a few different ways you'll see multiplication being written down. Sometimes you'll see this standard multiplication symbol, other times you'll just see a dot, and sometimes you'll even just see two variables written next to each other. All of these mean the same thing. We're multiplying b and h. Now the area of a rectangle is always equal to its base times its height, even when the base and height are not whole numbers. For example, consider this rectangle, which has a base of 4.5 and a height of 6. Using the formula we just found, what's the area of this rectangle? Right. The area of this rectangle is 4.5 times 6, which equals 27. And we can double-check this answer by counting the number of unit squares that fit inside the rectangle. So here are 24 unit squares. But don't forget, we have some leftover halves of squares over here. We can combine them to make 3 more squares, giving us a total of 27 unit squares, which is exactly the area you already calculated. Try out one more question. Suppose you have a square with side length s. What's the area of this square? Right. Because this is a square, that means all of its sides have the same length. So the base is s and the height is also s. And so you found that the area of this square equals s times s, which can also be written like this. You can read this as s raised to the second power, or perhaps more appropriately as s squared. So to summarize, if you have a rectangle, then the area of the rectangle is always equal to the length of its base times the length of its height.